Let's calculate the distance using the Hubble-Lemaitre law. We want to find the distance to the Sombrero galaxy. Here's an image of the Sombrero galaxy as taken from the Hubble Space Telescope, which is owned and operated by NASA and ESA. We're given that the radial velocity of the Sombrero galaxy is positive 1025 kilometers per second. So this galaxy is moving away from us at a speed of 1025 kilometers per second. We want to find the distance to this galaxy in units of megaparsecs. Mega is 10 to the 6, so you can say megaparsecs or a million parsecs. We're given the Hubble-Lemaitre law where speed or velocity v is equal to h naught d, where h naught is Hubble's constant, and in this particular case we're given Hubble's constant is equal to 68 kilometers per second per megaparsec. So we want to solve for distance given this equation and the radial velocity. Well, let's identify variables and values. We're given the radial velocity of 1025. Well, we know that that is the v value, and h naught is given to us, so the only thing we need to solve for is d. So let's substitute in what we can. We know h naught is 68 kilometers per second per megaparsec. So I'm going to make a small kilometers per second on the top to go at 68. And then I'm going to put a big divide by symbol and put megaparsec underneath. So now it says kilometers per second per, meaning divide by, megaparsec. And then we have our d on the right-hand side. On the left-hand side, we're given 1025, and the units are kilometers per second. Now we're going to divide out like letters, since we have like letters on the left and right-hand side of the equation. We have kilometers per second on the right-hand side, and we have kilometers per second on the left-hand side. And so the only thing is left is d megaparsecs, 68 and 1025, and they're all different. We can't eliminate them. But what we can do now is, since we want to isolate d on the right-hand side, we can divide by what we don't want. So we have a 68 on the top, so we divide by a 68 on the bottom on both sides of the equation. So let's do the same thing on the left-hand side. So we divide by 68. And now we have a megaparsec that's in the denominator, so we want to put a megaparsec in the numerator. Same thing with the other side. And now let's eliminate what we can. So on the right-hand side, we've got a megaparsec in the numerator, a megaparsec in the denominator, a 68 in the denominator, and a 68 in the numerator. The only thing that we're left with on the right-hand side is d. So I'll put an equal sign with a d. On the left-hand side, we're given megaparsec is the only thing that's left on the top. And then we're just given numbers. We have a 1025 divided by 68. So we go to our calculator, our online calculator. All I did was go to Google and type in calculator, and this is what I got. And I'm going to divide by 68. So I put 1025 divided by 68 equals, and it's 15, and we're going to round this 0.07. Since 7 is greater than 5, the 0 kicks up to 1. So we're going to put in here 15.1. And so our answer is the distance to the Sombrero galaxy is 15.1 megaparsecs using the Hubble-Lemaitre law. Now the actual distance to the Sombrero galaxy is 10 megaparsecs, not 15. We're off, and we're off because we're using the Hubble-Lemaitre law to find the distance to a nearby galaxy, which is the Sombrero galaxy. You only use the Hubble-Lemaitre law to find distances to faraway galaxies, distances that you cannot find by another method. So if we could find a Cepheid variable in this galaxy, or we could find a supernova in this galaxy, that is a better technique to find the distance to this galaxy than the Hubble-Lemaitre law. The Hubble-Lemaitre law is a catch-all for the furthest galaxies to find the distances to those galaxies. We did use it for the Sombrero galaxy to show you that we're off by about 1/3 the distance to the galaxy using this law.